Hello, welcome to this tutorial series of design patterns. I am Balasubramanian. Today we are going to look into a pattern called proxy pattern. This pattern falls under structural pattern. Structural patterns helps us to organize objects the objects as part of a bigger system that we are building and enabling reusability. So let's look into what does this proxy pattern solves. We might have heard about network proxies which are installed in the interfaces when we are working, right? So what these proxies do, they act as a gateway and then they will allow somebody to enter inside or not. So those are or they might do forward the request on behalf of you or on behalf of the requester which performs certain operation. Proxy pattern it does exactly the same. Proxy pattern is a structural pattern. In its general form is a class functioning as an interface to another class. A proxy lies in between. It acts as if it is the original resource, and that's what has been said in the first statement. Proxy can interface anything. It may be a database, it may be a network connection, it may be an object in memory or a file system. So proxy will serve as an interface between the caller and the called, and it serves the resource on behalf of the uh, called. Okay. Uh, Proxy is a wrapper or an agent that is being called by the client to access the real object behind the scene. Proxy forwards the request to the real object. Proxy is a wrapper. Here proxy serves as a wrapper or an agent, and it is been called by so the client calls the proxy. The client will not know the real existence of the resource. So when the client doesn't know, we might the proxy will stand in between, and it might perform certain operations on behalf of the called resource, and it may serve the object. So the client calls the proxy. The proxy forwards the request to the real object. That's been told in this statement. So let's look into the next. Proxy mostly is not a dump forwarder. When we looked into proxy forwards the request on behalf of the requester, and when we say that proxy is not just a dump forwarder, right? Forwarder. So it is not. It can also be used as a dump forwarder, so that if most of the hits are coming here, so it can act as an interface and then forwards to certain set of resources which might be distributed. But usually it is not a dump forwarder. It can perform authorization on the behalf to restrict certain access to subset of the object, or it may cache the response received already and serve the request on behalf of the server, so that the call in such cases the network call might take more time, right? So for example, if you are accessing a resource from the file system, and it is going to take more time to read that resource, when the resource is first read from the underlying system or from the network storage, the resource may be cached, and proxy may serve the resource from the cache and assume that the resource is not getting modified as frequent as we think of. So these are the situations when proxy pattern comes into picture. For the client interacting with proxy, it is transparent. The client will not be aware whether it is operating with the real object or the proxy one. Since proxy acts as an intermediary between the caller and the called, the caller will not know or will not be even aware of whether they are interacting with the proxy one or the real object. That is the beauty of this pattern. What does it mean? They both have to adhere to a common interface. That is what is the underlying principle behind this. So what are the problems which proxy pattern solves? Proxy pattern solves the problem of controlled access to the underlying object. For example, if there is a resource which has to be accessed only by set of people, right? What we can do is we can have a proxy in between the resource, and whatever authorization that we have to perform on behalf of the caller can be done here, because the resource will only serve the underlying object will only know how to serve it. We need not overload that with authorization and other things, right? So the authorization can be called can be done from the proxy side, so that if the authorization or the other things needs to be modified, we can only modify from the proxy side, not from the underlying resource side, right? So the authorization mechanisms may change. We may introduce new few more authorizations. In that sense, whatever the code which the underlying resource serves or the underlying object serves, that is already tested. We need not go and modify that. The only the place where the authorization is implemented, only the proxy undergoes the change, not the underlying object. So it means that any functionality we may need to add on top of the resource, we might be able to add without modifying the underlying resource or underlying class, right? Additional functionality should be provided to the response as received, such as wrapping the result with metadata. This is an important point which we need to understand. For example, when we are accessing a resource, for example, in a REST service, we will go and access a service to get the data. What we do is, usually on top of that, we will wrap the response with certain headers. What is the time taken, or and we might need to add certain headers, right, served by this person. So all these things can be done at the proxy layer. For in considering the in the world of microservices that we build, controller is controller, the model view controller side, controller acts as a proxy. REST controller is the one which acts as a proxy, and it goes and accesses calls the underlying resource of the database or a file system, and it serves the resource back to it. In the controller side, what we do, we wrap the response with certain headers. We may massage the response by adding additional responses on top of it. For example, status. If there is an error when we access this, we will wrap that with the appropriate errors, and also controllers access a proxy in terms of the RESTful architecture that we take in the model view controller architecture. That's a good point that we can make you we can understand. This is the real use case, right? Proxy is used in controllers. Proxy is also used in networks. Yeah, as I said, network, there are a lot of network proxies. We never access the network proxies are the one which forwards the request on behalf of us. Proxy is also used as a pattern in certain scenarios where the resources are cached and served. Since the underlying resource access may add latency to the object, in case the object is a remote object. Consider in terms of distributed systems. In distributed system, certain objects might be in remote, and those objects usually don't change, right? They are not frequently modified. What we do is, we might cache the responses and then we will send. If we need to send the responses back very quickly, what we can do is, we can have a proxy layer and cache the response for a certain amount of time, and till that time limit exceeds, or till the time to live is there, we need not go and access the underlying network resource, which might be a costly operation. We can serve it from the cache. These are the practical use cases of proxy. With that being said, let's directly go into and look into the UML diagram of proxy. So as we pointed out, let me minimize this. This is the UML diagram for proxy design pattern. So we are going to look into a proxy for we have come up with a sample for a file service, right? What this does, there is a service that we have designed which goes and accesses the underlying files and serves the contents back as a response. So what proxy does is, proxy here I have used proxy to cache the resource and send it back, because of the fact that the files are not going to get changed as and when it is for a period of time. So what I have thought about this example is, the proxy acts as a intermediary between the client and the actual resource. It will go and check based on the file which is being requested by the client. If the client if the file is already in the cache, it would serve from the cache. Otherwise, it goes and reads it gets the file from the actual implementation and serves the result back. So consider this scenario. For example, the file is in a remote location where it is stored in S3. Consider S3 is a AWS S3 or any other Azure Blob storage, or the NAS file system which is located in the far data centers. and the proxies are a little near to the called person. So we need not go and access those resources immediately as and when we want it, and assume these files are little smaller in sizes and I can keep it, or somebody can cache it and send. So what I have implemented is the client calls the proxy when the file exists, it will serve from the cache, otherwise it goes and does it. It's a very simple pattern, but the usage of it is it is very simple and effective pattern. It can be used in various scenarios. For example, as I said, right, the REST controller itself you can think of as a proxy pattern, because it wraps the in terms of layered architecture, even in the domain driven, every request REST request hits the controller. From the controller only it gets the controller decides which is the underlying resource that the controller needs to call, and it says the response back, right? So controller itself is a proxy. We will go and hit the controller and requesting for a resource, right? Similar is the case. I've used this proxy service, so everybody will call the proxy service. If you take the proxy service, the interface is file service, and it has a method called get file, which takes in the parameter of file name as the string, and it returns the file back. The file service implementation is the actual service which goes and looks for the file and returns the file back, and proxy is the one which caches that file if post receiving it, and then sends the response to the caller with the file. If we note it, and the file has the other properties like string, file name, content, and the path. If we note it here, this is a relationship. The proxy service is a file service, and it also has an instance of file service, because the proxy has to use the file service to access the underlying resource. Proxy will not know the logic, or will not have the logic to access the file, because that is a complex process which is involved, which is been cooked into the file service. The proxy will not implement the exact file service, but proxy will adhere to the signature of the file service. But what it does is it has an instance of file service implementation, and then utilizes this file service to call the actual underlying resource. In this case, the proxy is a file service, and it also has a file service. That is the thing which we need to understand. So it also has a is and has a relationship is maintained in this this is maintained by the proxy implementation of it. I hope the explanation would be clear. Let's look into the code. So let me go into the gang of four patterns. Structural proxy file. As I said, the file is the underlying resource. I have just mimicked the file with certain properties. Assume the file may contain more properties, right? I've used three properties. One is file path, which is very important when we access the file. File name is very important, and the content, the content is very important. So we may also add authorization related rules in the proxy, but that we will look into it a little later. I'll once we finish the demo, I'll explain the use case where we can add this authorization and other things. So the file service is the underlying service which will be implemented by the file service implementation as well as the proxy file service implementation. It has a method called get file, which takes in a parameter of name and returns the file resource back, and the resource is what we have looked as file, right? It has the name, path, and the content. So let's look into the file service implementation. The file service implementation has implements the file service. I'm saying that I'm loading the file from the disk because we are directly loading the file from the disk only. If we note it here, I have two files, file 1, file 2 in this resources folder. I'm going to access those files only. Assume this is a network location, right? This we are accessing from the local, and if it is going to be a network location, it is good to cache it, right? And that is the underlying scenario that we are trying to simulate. Let's see how am I going to cache it. So what I'm doing is I'm accessing the resource. I'm accessing the file from the folder where we have which are in the resources. I'm using the get class loader get resource. We will give the resource file path, and then since it is under the static folder, I'm appending static and then appending the file name and getting it. I'm reading the contents using the files.read string method, and I have created. I used the paths.get to get the file in there. I used the UTF-8 as a char set. So I'm instantiating a new file object, I am setting the content to the content which I have read, and set the file name to the name which I have received, and path, I'm using the file that get path, the actual file that get path, and I'm returning the file. This is an implementation. While we access the file, there are certain exceptions that we need to handle. Whether we might get a UI exception, we might form the URI, we might get a URI exception if the path is not formed correctly. So those are the exceptions which are caught. If when the file exists, I'm going to return. Otherwise, I'm going to return null. So let's go into the proxy file implementation. The proxy file implementation, as I said, proxy file implementation is a file service, and it also has a file service, because the underlying logic of opening the file and closing the file, reading the content and sending it back should not be here. Proxy will forward the request, as I said, right? It will forward the request. It is not going to do the operation that it is supposed to do, right? It just forwards the request by calling the underlying service. Since it has to call the underlying service, I'm maintaining that object. So it has to have follow the has. It also has a file service, and it is also a file service. I have just maintained a map here, which is a hash map of a key which is string, and the value is the file. So I'll go and check whenever a request comes, whether the file, the hash map contains the name. If it contains, it returns from the cache. So assume that it is going to access the underlying resource, which is a remote object. It is not going to do it. It returns from the local in memory, right? Otherwise, it is going to get the file from the underlying implementation, file service implementation, and that's what we called here. And if there might be scenarios where if the file doesn't exist, right? If it is equal to null, I am returning null. Otherwise, I am adding that resource to the cache and then returning the file. This is what I am doing, right? The proxy forwards the request. It might do caching as well, right? So that's what we are doing. We are doing a caching here and then returning the file. Let's go into the main method. What I did, I've instantiated the proxy file service, and I am requesting for a first file named file1.txt. I am requesting the file2.txt, and I am printing the file1's content and file2 content. So I'll put this out, 20 of file1. So I'm going to copy paste the same here, contents of file2, again contents of file1. This is file. So let us see how this works. I'll run this. I'll debug and show as well. So if we see what are the contents of file1, file1 contains file1 content, file1 content is 10 lines, file2 contains file2 content 8 lines. So if we see here, the method, it should print 2 times file1 content and 1 times file2 content. So first of all, it prints the contents of file1, and it prints the contents of file2, and it prints the contents of file1. The third time when we call it, it should not go and get the file. So let us debug and see whether the caching works or not, because that's the implementation of proxy, right? Proxy service implementation. Put a breakpoint here. Let me run. I'm debugging and showing so that things will be clear. So let us see when the breakpoint hits. Just a second, it is debugging. So the first request came, it is for file1. I am saying F8 because the file is not in the cache, because the cache itself is null. It does not, the size is 0. It goes and fetches it from the appropriate resource. It assume like this is a network call, and it returns the file. Since the file is not null, it is putting the file name inside, and then it returns the file in the cache and put. So now the file2 is getting accessed. So file2 is also not in the cache, because already, if you see, files is the hash map, it contains already file1. Since the file is not null, and it is putting in the cache and returning the file. So now when it is getting the content, it is getting the content from the returned object. I'm pressing F8, it is going to return the content from the cache. Now I am calling for the third time. F8. So if it goes, okay, so now I'm going and checking if the cache contains the file 1. So it checks, so now it returns from the cache. It doesn't go and access the resource. Now the resource is getting served from the cache. That is what I want to show it here. So the what is the advantage of this? So we are able to cache the resource. Assume that we want to authorize certain resources. For example, only certain users are allowed to access the complete file. For others, only we need to send certain responses from the file. For example, only headers are allowed to be seen, or not the entire content should not be seen. All this authorization can come here. So it can take in some parameter like the username, and it can we can do all the authorization here. When the username, we can do against an LDAP authorization or a OAuth based whatever authorization mechanism. Forget, let's not go into the details of what authorization principle we are going to use to authorize, but assume that only when the users belonging to certain group are supposed to be served, otherwise we should return 404 or a 403 forbidden response. We can do all the operations here. What happens if we are going and implementing the authorization at the time of calling the resource or from the resource serving end, the entire network call is made, so that is waste of resources. What we can do, proxy can do all the authorization which it has to do